All right, guys, so here we go. Here's this worksheet we were talking about, so let's get a jump on it. So before you do anything, make sure your name is written up here where it says name. That way when you turn it in, you'll actually get credit for it. All right, so it says, starting at the top, carbon atoms have blank electrons available for bonding. How many is that? 4. Okay, so those electrons are called what? Those electrons are called what? The outer level electrons that are available to chemical bond. Starts with a V. Valence. You got to speak up. Okay, they're called valence electrons. To become stable, carbon atoms can form 4 what bonds with other atoms? Help me out here. Covalent. Yes, covalent bonds. Carbon atoms can bond to other blank atoms, so other carbon atoms. Or other elements like hydrogen. What else? Oxygen. Or nitrogen to form straight chains, branched chains, or rings. Okay, they can form straight chains, branched chains, or rings. Sometimes carbon can share one electron pair with another atom, but sometimes multiple bonds are formed between one carbon atom and another atom of carbon or something else when 2 or 3 electrons are shared at the same time. So one dash indicates, or one dash between elements indicates what type of bond? It's what a lot of you are. Ha, ha, got jokes. Okay, so one line is a single bond. So remember, if you do the thing with the fingers, how many electrons are being shared in a single bond? 2. All right, 2 dashes indicates a double bond, and 3 is a triple. How many electrons are being shared in a double bond? How many? Okay, do the finger thing again. So how many electrons in a single bond? How many in a double bond? 4. How many in a triple bond? 6. Easy to remember, right? Compounds. Compounds that have the same blank can differ in blank. So the same chemical formula can differ in structure. Can everybody see the red okay? Yeah. Okay, they can differ in structure. So what that means, it says these compounds that have the same formula but different structures are called what? What was the word we had for that yesterday? Think back to yesterday. Starts with the letter I. Isomer. Good. Isomer. It's called an isomer. And it says blank, blank, and blank are isomers because they all have the same chemical blank. But so what were the 3 examples I gave you of isomers of each other? Glucose, fructose, and galactose. Sounds like it's from outer space. Because they all have the same chemical formula. And for this one, we'll actually write it in. The chemical formula for those 3 is C6 H12O6. So they all have the same chemical formula, C6H12O6, but different structure. They have a different structure. Hey, see that last sentence? Don't know why it's repeated in there. Okay, moving down, it says simple molecules that can exist alone or be combined in long chains are called what? We may have called them building blocks. What's another name for the building blocks? Starts with an M. There you go. How many of y'all are realizing that you know more of this than you think you do? You just got to think about it a little bit. When many monomers are linking into long chains, what is formed? Polymer is formed. Large molecules made of hundreds or thousands of carbon atoms are called what? Let's say organic macromolecules. Why organic? What tells us that it's organic? Because they contain what atoms? Carbon atoms. There you go. When you hear organic, you got to associate carbon with it. It says when water molecules, bless you, when molecules are combined to form polymers by releasing a water molecule from their hydrogen and hydroxide ions in their chemical structure, a reaction called blank or blank occurs. So the name for the reaction is actually called condensation. It's a condensation reaction. But what did we call it yesterday? Dehydration synthesis. Dehydration synthesis. So when you think about, y'all ever heard of condensed milk? Why is it called condensed milk? Because what have you removed out of it? Why is it condensed? When you condense something, that means you pack it tighter, right? And so you can pack milk tighter when you remove water from it. So that's why it's called condensed milk, is because you've actually removed some of the water from it. So if you look, here's a great illustration of what a condensation reaction or dehydration synthesis reaction looks like. So what's going on here, look, is the OH from this one and the hydrogen from right there are leaving and make water. And so it's showing that there's the water coming out, and the bond is left with that oxygen in the middle. Okay, so an OH plus an H comes out, forms a water molecule. So let's do an example of this. Let's say I've got, so these two, this is two disaccharides. So let's say I've got C6H12O6 plus C6H12O6, right? What do we know is going to come out? A water molecule, right? So we're subtracting H2O. So if we add these together, what's my new formula? Okay, so we're going to have C what? Adding those together. What's 6 plus 6? 12. What's 12 plus 12? 24 minus how many? So what's that going to be? 22. And then O, we have 6 plus 6 minus how many? So what's 12 minus, what's 12 minus 1? Do we still follow the 2-to-1 pattern? Do I have 2 hydrogens for every 1 oxygen? Yes. Are y'all paying attention? So does that make sense, how we got that? You're joining the two of them together, but you're removing a molecule of water, and that's why your formula is what it is. All right, let's go to the next page. All right, so a hydrolysis reaction literally means breaking apart with water. So this is showing how you have two joined together. You have lactose joined together. You're going to add a molecule of water, and it's going to break it apart into its two parts. Okay, so that chemical process is called hydrolysis. And so that's the breaking apart with the addition of water. It's the reverse of condensation or dehydration synthesis. Easy peasy. Yes. Oh, why? It's written right up here, Colin, at the top. It's this word right here. Instead of hydrolysis. Yeah, it's just the way the accepted way it's been pronounced. Hydrolysis. All right, so guys, please quit talking. Look at these next diagrams. So these are your 5 monosaccharides that you're responsible for knowing. Here's why they're drawn the way they are. So each place we see either a carbon or a joint right here is going to represent a carbon So let's label how many carbons we have. 1, 2, 3, 4, 5, 6. Why not here? Because it's got a what in it? It's got an oxygen right there. So how many carbons does this one have? How many carbons? 6, right? Let's look at the next one. Okay, it's a little different shape. It looks like a pentagon, but let's count the number of carbons. 1, 2, 3, 4, 5, 6. It's still got 6 carbons. Let's do the last one. 1, 2, 3, 4, 5, and 6. So these are the 3 hexose monosaccharides. And why do we call them hexose? Because they have how many carbons? 6 carbons. Where these two right here are the pentose, which means they have how many carbons? 5 carbons. Then if we label them 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? This is how you count carbons in organic chemistry, is because it gets kind of busy if you write the formulas out. So you just do the little shorthand, and everywhere you have an angle is going to represent a what? What kind of atom? Say it one more time. Carbon. There you go. All right, so it says the category of organic compounds that is used by cells for energy is the what? Carbohydrates. These compounds are composed of only the elements carbon, hydrogen, and what? What were the elements that made up a carbohydrate, guys? Carbon, hydrogen, and oxygen. This should not be new. These compounds have 2 hydrogen atoms and 1 oxygen atom for every 1 carbon. The simplest type of carbohydrate is called a what? What's the simplest of our carbohydrates? Starts with an M. Monosaccharide. It's called a monosaccharide, which are how many ringed sugar molecules? 1 ringed sugar molecules. And so now we're going to list the 3 of them. Or actually the 2 categories. So the first category are the hexose. which have how many carbons? 6. Our example of the hexose ones were glucose. What else? Fructose. And galactose. Better? Okay. Then we had the pentose, which had how many carbons? Say it loud. There you go. Okay, and that was ribose and deoxyribose. Ribose and deoxyribose. Y'all see that okay? Okay, so next page it says blank is the monosaccharide used by all your cells during blank blank to produce ATP. So that would be glucose. Glucose is the monosaccharide. Glucose is a monosaccharide used by cells during the process of cellular cellular respiration. So, ATP, moving on to the next one, where it says blank is the sweetest monosaccharide that's found in fruit. So what's that one? Fruit, sounds like fruit. Fructose. Where have we heard fructose at before, guys? High fructose corn syrup. So listen, most of your soft drinks for probably the past 30 years have been sweetened with high fructose corn syrup. So let me see yours real quick. So if we look at Colby's Pepsi and we look at the ingredients, the first ingredient, y'all know about like the ingredients, the closer it is to the top of the list, the more percentage it is in there, right? No. So in Pepsi, the number 1 ingredient, carbonated water, duh. Number 2 ingredient, high fructose corn syrup, then caramel color, sugar, phosphoric acid, caffeine, citric acid, natural flavor. Okay? So most of your soft drinks have been sweetened with high fructose corn syrup. The reason why is the price of sugar got up so high that soft drink manufacturers were actually losing money, or they were going to have to really raise the price of soft drinks back in like the 70s. And so they decided to start using high fructose corn syrup instead, and now your palate is so used to it that because it's sweeter than sugar, if you actually tried something different, it's not going to taste the same. Like, how many of y'all drank the Pepsi throwback or the Mountain Dew throwback a couple years ago? It tastes good, but it's different, right? I like the one. Now, Mexican Coke, there's a great example. Mexican Coke is still sweetened with sugar, okay? And it tastes different than high fructose corn syrup Coke.
So my dad said that,
Hey, y'all listen. Well, not only did they try to make Coke with real sugar, they actually changed the formula of it. That was like back in the 80s, and they called it New Coke. At one time, it had trace amounts. It was it wasn't cocaine. It was actually the plant that cocaine is derived from. They had an extract of that in it. But that was like back in the 20s. This was back in the 1920s. Yeah. What's the, we used to have like folks from our church that would go. So fructose is the sweeter monosaccharide found in fruit. What's the monosaccharide found in milk? Galactose. Okay. Now, the reason why it's not lactose is because it's actually referring to the actual monosaccharide. Okay. And then the monosaccharide used or found in DNA. Deoxyribose. Now, if it said RNA, it would be. Nope. It'd be ribose. That's where it gets its name. Okay. It stands for deoxyribose nucleic acid. And when we get into nucleic acids, that'll make more sense. All right. So here are the 5 monosaccharides again and their shapes. All right. So, moving on. If it's a double sugar, it's called a what? Disaccharide. Disaccharide. They're composed of 2 whats? Monosaccharides. Composed of 2 monosaccharides chemically bonded through the process of dehydration, synthesis. That keeps coming up over and over again, right? So it must be important, as Adam says. Okay? Dehydration, synthesis. An example of a disaccharide is blank, which is better known as table sugar. Sucrose. Sucrose. Sucrose is formed when blank bonds to blank through a blank reaction. So glucose bonds to a fructose through a what reaction? What was the other name besides dehydration synthesis? Started with C. Condensation. Condensation reaction. All right, here is a diagram of the 3 disaccharides that you're going to be responsible for knowing. And look, it even tells you what makes up each one. Now, what do we know they all have in common? Well, they all end with those, but they all have glucose as part of them, right? I need some new headphones. I need a pair of Beats. I need those in my life. So there's the disaccharides. All right, next page. Polysaccharides. Okay, so take a look at these. What do you notice? What's the difference between amylose and amylopectin? Okay, so amylose is just a single chain of monosaccharides. That's what each of those little hexagons is. Where amylopectin is what? It kind of branches off, right? Is it still a bunch of monosaccharides put together? Yes. All right, what about glycogen? What's the difference between glycogen and amylopectin? Yeah, it's more heavy. It's like what we call like compound branched, right? There's a lot more branches to it. And then what about cellulose? Cellulose looks like a block, doesn't it? Okay, and if we know what we know from yesterday about polysaccharides, then that makes sense as far as cellulose go, because it's not used for energy storage, it's used for building things, right? So if you were to build something out of the 4 of those, which one looks like the one you'd probably build something out of? The block, right? So that's what makes sense. All right, so it says the largest of our carbohydrates is called a what? Polysaccharides. Polysaccharide. 3 examples of polysaccharides within living things and their survival are starch, glycogen, and cellulose. Okay, so amylose and amylopectin both fall under the category of a food storage polysaccharide found in a plant. And what's the general term we have for those? Starch. Okay? And starch can be many forms. So you think of a potato, right? Or corn. Okay? Anybody ever heard of cornstarch? Yeah, that's what you make what from? What you make out of cornstarch? Or cornmeal. Cornbread, tortillas, there you go. Yeah, you can make that oobleck out of cornstarch. What about bread? What is bread made out of?
Yeast.
No, not yeast. Wheat, flour. Okay, so flour, guys, ground up grain is starch. Okay? Anybody know anybody in here that's like has to eat a gluten-free diet? Okay, so Maggie Grace, my 6-year-old, when she was about 1 or 2, she had like severe food allergies. And so we went to the allergist and we had to take her like off of pretty much everything. She was allergic to like milk, eggs, soy, wheat, you name it, she was allergic to it. Like she was basically allergic to everything but like life. Well, so we survived that summer on gluten-free chicken strips, which is crazy expensive, by the way. Mott's fruit gummies, and cheese dip, rice and cheese dip from the Mexican restaurant. Because the milk allergy, she was allergic to cow's milk, but she could have goat milk, which the cheese at the Mexican restaurants made from goat milk. And we found that out because anytime she'd come in contact with like regular milk, she'd break out. She'd eat cheese dip, nothing. So that's how we ruled that out. And she's kind of outgrown a lot of them. But so like the gluten-free stuff, we're having to do all this gluten-free cooking. And so we're buying stuff that has like potato flour in it, or rice flour, or tapioca flour. Like, let me tell you, guys, there's nothing worse in the world than a gluten-free brownie. It's like, you know, like those silicone oven mitts?
Ew.
It's like eating a chocolate one of those. It was disgusting.
Did it have a flavor?
No, it was awful.
Why'd you eat it?
Well, we made it, and we didn't want to waste it, right? And I can't ask the kid to eat it if I'm not going to eat it, right? So just wait. You'll be there one day. You'll be there one day. Yeah, it's gotten better because like she's like things that still. It's crazy because like English peas. She had English peas at daycare one day, and that almost sent us to the hospital. Like hives, we thought we were going to have to pop her with an EpiPen. That's how bad it was. But it's gotten better. She can eat a lot more things now, but it sucked because like right at the time she was starting to learn how to eat new foods, we had to like take her off of everything. So now she's like uber picky eater. And then my youngest child's like a garbage disposal. We haven't found anything she won't eat. So, which is helpful, but. All right, so it says the molecule, y'all listen, the molecule blank is more highly branched than starch, but similar and used for energy storage in animals. Glycogen. Okay, so glycogen is more branched than starch, but similar, used by energy storage by animals. And blank is the polysaccharide that forms a cell wall of plants. So that's cellulose. And it's normally referred to as what? Dietary Fiber. Yeah, you're getting fiber in your diet. All right, so it says blank is also a structural carbohydrate. It's the polysaccharide that forms the cell wall of fungi and the exoskeleton of arthropods, and that was called chitin. Chitin. Chi. C-H-I is pronounced chi. Chitin. And then the last one says, while blank is a polysaccharide that forms the cell wall of bacteria. I'm going to have to zoom in on that one. Peptidoglycan. 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 All right, look at the last question. What material forms the cell walls of animal cells? What's making the cell walls of an animal cells? Read the question again.
Animals don't have
Boom! Nothing.
That's super hard.
Trick question. Because animal cells don't have a cell wall. I like to make you think. It's supposed to confuse you. All right, carbohydrates. So this is kind of a summary chart of all what we talked about. So this is kind of summing it up real quick before we play quizzes and take our quiz. All right. So carbohydrates. What are the three categories of carbohydrates? Let's fill that in first. Depends on how many. So you got mono.
How many attempts do we get on the quiz?
You got monosaccharides, you got what, and you got what? Disaccharides. And you got polysaccharides. Monosaccharides, polysaccharides, and disaccharides. So this is 1 sugar, 2 sugars, many sugars, 2 plus. Okay, so the general structure, so a monosaccharide is just going to be like that, 1 ring.
So what?
It's like a hexagon. A disaccharide is going to be 2 rings hooked together. Polysaccharides, we're going to say C top. Okay?
I tried to draw that thing. But
Because polysaccharides, I mean, there's a bunch of them, right? Could be hundreds or thousands hooked together. Okay, so our examples. In monosaccharides, we're going to break it down to 6 carbon and 5 carbon. So what's another word for 6 carbon? Hexose. 5 carbon is pentose. Hey, there we go, Tyran. Y'all hang on. Tyran's back in business. Okay, so what are the 6 carbon sugars? What were the examples? Glucose. Look at Tyran go. He knows this. Glucose, fructose. Nope. Not lactose. Galactose. All right, and then the 5 carbons were ribose and what? Deoxyribose. Okay. Disaccharides, easy. You've got sucrose, lactose, maltose. Okay, let's talk about what makes them up. What makes up sucrose? Glucose plus fructose. Lactose is glucose plus galactose. I'm just abbreviating. And then maltose is glucose plus what? Glucose. Glucose plus glucose. Come on, Jake. He's trying to give you Tatarian lessons. All right, and then polysaccharides. Examples. So we got starch. And what's the other energy storage one in people or in human or in animals? Glycogen. Okay, and then the structural ones were cellulose, chitin, peptidoglycan. Peptidoglycan. I need to just let Tyran teach this. He could do it.